Hello, I'm Ana Laura Gerson Apio, and I'm going to present about codec binary and transmission of information. In history, humanity has always been evolved with technology and mathematics. What happens to this day, especially in computational mathematics? One of the ways that mathematics finds its way into technology is through binary code. We live in a globalized world. That is, information goes from one side of the world to the other in a matter of seconds, greatly increasing communication. This happens because of the technology programs we create based on mathematics. Behind this technology, we need codes so the programs can work. So, we will talk about the code that makes everything work and how this code works. But what binary code does? It allows the representation and manipulation of information, runs programs and applications, transmit information like messages, audio, images, and videos. This code has two digits, 0 and 1. 1 digit represents 1 bit, 8 digits represent 1 byte. Binary code works with base 2, and the place where the digit is in the code defines the exponent. These digits are the information we receive on a daily basis via technology. The letters in messages, the colors in photos, and the sound in the audio are transformed into binary code to be shared on communication channels by your computers. When we send a message, the computer transforms each letter into a sequence of 8 bits or 1 byte. The colors of the images are captured by the RGB sensor. The uncaptured colors are represented by 0 and the captured colors are represented by 1. Images on social media are formed by pixels which are represented by 8 bits per color, captured by the sensor in total of 24 bits per pixel. 8 bits is equal to 2 to the 8th power. As there are 3 colors, a pixel is 2 24 power, meaning there are 16,777,216 colors. To calculate how many bits an image can have, multiply the pixel resolution of the image times the number of bits per pixel. So, if an image was 1038 H, 1350 wide, and 24 bits per pixel, how many bits would that image have? The image bits would be equal to 1030 times 1315 times 24, which would be equal to 34,992,000. Sound is captured as an analogic wave and converted to digital data by the analog to digital converter ADC through sampling and quantization. The wave is measured at regular intervals, converted to numbers, and they encoded as binary to create a digital audio file. And how do you find out the number of bits in an audio? To find out the number of bits in an audio, you must multiply the sample rate times bit depth times number of channels times number of seconds. If I send an audio with 44,100 Hz, 16-bit quality, 2 audio channels, and 20 seconds, how many bits will the audio have in total? The bits of the audio would be equal to 4,400 and 100 times 2 times 16 times 20, which would be equal to 28,224,000. And how do you find out the number of bits in a video? To find out the number of bits in a video, you must multiply the pixel resolution times frame rate per second times bit depth times duration in seconds. If I make a video with 1008 pixels wide times 1350 pixels height, 30 frames per second, 24 bit depth, and 30 seconds, how many bits will the video have in total? The bits of the audio is equal to 1008 times 1350 times 30 times 24 times 30 equal to 31,492,800,000 bits. As binary code is nothing less than information, it takes up space, that is, amount of MB. When we save a digital image, it takes up space in your computer, and space can be measured in MB, megabytes, or MEB, megabytes, depending on the context. Although they sound the same, MB and MEB represent different amounts of data. The megabyte uses binary system, based on powers of 2. 1 megabyte is equal to 1,048,576 bytes, or 1024 times 1024. It's common everyday used in programming operating system and when you want to accurately measure the size of files, such as raw images or backup. But the megabyte uses the decimal system, based on powers of 10. 1 megabyte is equal to 1 million bytes or 1000 times 1000. Megabyte is used to measure digital storage and data. It appears in file size, depth storage, internet plan, apps, games, cloud storage, and email attachment limits. Even though the megabyte is more popular understanding and using the megabyte, it's essential in technical and professional contexts, where every byte counts, such as in servers, programming, or large files, such as uncompressed images. Let's compare them through calculations. Megabyte is equal to amount of bytes divided by 8,388,608, or 1024 bytes, 1008 bits. So the image from previous example would be 34,992,000 divided by 8,388,000, that is equal to approximately 4.17 megabytes. The audio from previous example would be 24,224,000 divided by 8,388,000 equals to approximately 3.36 megabytes. The video from previous example would be 31,492,800,000 divided by 8,388,608 equals to 3,007.54.23 megabytes. And what would megabytes look like? Megabyte is equal to amount of bytes divided by 8 million or 1000 bytes times 8 bits. So the image from previous example would be 34,992,000 divided by 8 millions, that equal to 4.374 MB. The audio from previous example would be 28,224,000 divided by 8 million, that's equal to 3.528 MB. The video from the previous example would be 31,492,800,000 divided by 8 million, that's equal to 3,936.6 MB. But these numbers are larger than we normally see. This is because they not have been compressed yet. Compression is a process of reducing the size of files, such images, videos, audios, or text, by removing redundant or unnecessary data, so they take up less space in memory or are fast to transmit. In other words, the same file but without unnecessary sequence of binary code. The 4.17 megabyte image compressed would be 4.17 divided by 10, that is equal to 0.417 megabytes. The 3.36 MB audio compressed would be 3.36 divided by 11, that is equal to 0.305 MB. A 3754.23 MB video compressed is equal to 3754.23 divided by 300, that's equal to 12.51 MB. The 4.374 MB image compressed would be 4.374 divided by 10, that's equal to 0.4374 megabytes. The 3.528 MB audio compressed would be 3.528 divided by 11, that equal to 0.3207 MB. The 3936.6 MB video compressed would be 3936.6 divided by 300 equal to 13.122 MB. And this is how we perceive the correlation between binary code and the information we see during your day.